What's up, guys? Ian Sandusky back here again for Practical Machinist for our live coverage of IMTS 2022. And right now we are stopping at the JW Dunn booth, the ORBITOOL deburring tools with my friend Stan.
How you doing?
Thank you very much for joining us today.
Yeah, my pleasure. Thanks.
How's the show been going so far?
Really, really busy. Total surprise for us. I think everyone, no one had an idea how it would be after 4 years off, and it's been pretty much nonstop.
Did you guys come to the last one?
We did. We've been here every time since 2014, and for me, I feel like our booth, this is the busiest we've ever been. It's pretty much nonstop demonstrations.
I know even before we started here, everybody who walks by is stopping, taking a look.
Yeah.
And why is that? What are we talking about today?
So it's a very simple thing. It's let's say a very simple solution, but it solves a very complicated problem. But
absolutely,
it's the ORBITOOL. That's why we exist. That's our reason for being. This is the tool, let's say, in its giant state.
This is real size, right?
Yeah, exactly. Yeah, if you want to deburr the real big stuff. So
right.
It's a flexible shank, and it's a protected ring here. So it's two very simple features, but that's what makes the tool so unique and make it work in applications that really no one else could do before. And then we have this carbide burr here. So the concept of this tool is that we're preloading that flexible shank. We're bending the tool against the surface of the whole wall, but we're not damaging that wall because of this protective ring. So what that allows us to do is, for cross-hole deburring, it's a very big challenge to remove the burrs where you need to remove material, but protect all these other adjacent surfaces without damaging them. So I can quickly show you how it works
absolutely.
by hand. We've got customers using them on a CNC as well. But basically, in just a hand grinder, we have this little flexible shank. And because of that protective ring there, I can just put it right on my fingernail. I don't do any damage.
And that's really, really important if you're trying to protect surface finish on the inside of holes,
absolutely,
on the back side of a phase.
Well, and specifically because, in general, if we look at finishing as a whole, and deburring also, but it's really the last step. So we've had customers tell us where they have this complex manifold, it's got 10 hours of work, it's literally at its most expensive state, then it goes to the deburring department, someone accidentally moves over a little bit in the wrong direction, slips a little bit, scratches the bore, and now that entire part is either scrap or needs to go back for rework. So deburring sort of doesn't get the attention it deserves, I think, especially when people are designing a part or machining the part. Deburring gets sent to do somewhere else, and it's a big cost kind of suck that people aren't not always.
Absolutely.
Yeah. So that's how someone would do it by hand. The beauty is, I mean, I can go fully with my eyes closed. I don't have to look at the part. I can just feel when the tool is hitting that edge, but I'm not damaging that bore at all. And on the inside, you can see that happening. If we find an intersection we haven't done here, I can just place the disc on that bore. I'm never damaging it. The moment I hit the edge, the burr flies off.
Oh, wow.
Yeah, it came right off there. And as I spend a little bit longer time, I can kind of tailor that edge from a deburr to just a light edge break to a truly controlled radius. But from the outside, the operator is just doing this by feel.
And the nice thing about it is, when you're doing this kind of thing, typically you don't want your highest paid, most skilled guys doing deburring.
Exactly right.
When you're doing really high finished stuff, you almost need them to so it doesn't get damaged. But if you're using something like this, you can get some of your newer guys or some of your,
and you're spot on with that, because we've had customers tell us where, you have a deburring department, but even within those folks, you kind of know this is the new person, this is the experienced person. If this is a part that we really need to get out the door today, you kind of know who to give it to. Or if they're out today, you kind of hold it for them tomorrow.
Right.
So it's what's called a craft-sensitive job. This, in a manual setting, allows anyone to do it. But even for the skilled people that are doing it, it makes their job faster, easier. So that's in a manual setting. Now, the big thing, let's say the key of this whole setup is for CNC deburring. That's what's always been a challenge. It's been virtually impossible in some intersections. For example, if we look at this, the graphics on the wall, the before and after, we're sort of showing the worst case scenario, which is called a 1-to-1 hole ratio.
Right.
That's always been the biggest challenge to deburr. Because with the 1-to-1 ratio, you have this edge. It's just kind of blending out and washing out into the wall.
Yep. Oh, no,
so you need a tool that's selectively removing material at the edge, removing less here, and protecting this surface. And that's very difficult to do. Even with complex programming,
yes,
you can try to achieve it, but the moment your drill walks away a little bit, the moment the intersection is, dimensionally not exactly where it is on the part or in the drawing, here, you could take that tool out here.
Yeah, and especially if you are going that long. Let's say we have to go into a hole that far. It doesn't matter how accurate your tool is, you got that much hanging.
That's exactly right. So now if we step over into the videos here, we can show how the tool works by hand.
Absolutely.
So the basic concept, just like I showed on the giant model, is, let's turn this back on. The basic concept, we've got that flexible shank, right? And we got that protective ring. Our computer decided to restart at the exact wrong moment here, so we'll bring that back up.
Yeah, no problem. And you guys can see here, this is a full line of these here. And as he said,
yeah, here we are.
We can move these very, very easily.
Yeah. So CNC settings. So here we'll see. We'll show a real video we're working on the machine, but here's a quick graphic here. So it's the same tool. What you'll notice here is I'm coming down and actually bending that shaft on the surface. So if I'll just rewind it real quick. That disc that we showed earlier, that protective ring is protecting that wall. And what you're seeing with that bouncing is that flexible shaft constantly adjusting. So what that means in practical terms is you don't have to program any sort of difficult contours. You're literally just making a helical interpolation path. And helical interpolation is just a fancy way to say spiral.
Yep, absolutely.
It's a standard canned cycle that every machine has. It's just like a thread milling routine.
We use it all the time for thread milling or for helix bores.
Exactly right. So we're coming in on center, offsetting the tool, and because we've got that flexible shaft, the moment the tool reaches the edge, it just automatically pops in there. But anytime we're in any other area, it's protecting that wall. And so from an operator standpoint, it's super easy. It doesn't matter where the edge is exactly. It doesn't matter what shape the edge is. We could have three holes, same diameter, with all sorts of different exits. You don't need to program a different contour for those exits. You just make that same spiral.
You don't even need to be able to see it.
Exactly right. You just kind of roughly say, I need to start at this Z, finish at this Z. So here's another video. This is a real video on the CNC. So there you can see the same cutter that we were using in a manual setting.
That
Let's
quick.
Go back a little bit. So we're going to see the inside, but the same cutter is just mounted directly in an ER, call it. You don't need to buy different tools for manual or CNC. Now inside the intersection, you can see that we're just making that same helical spiral. And we're making a very uniform, very controlled
I was going to say,
radius.
it's very consistent.
Yeah.
If you're not familiar with this, trying to get a consistent radius like that on the inside of something you can't see, it's frightening to think about.
Yeah, in particular when you have this three-dimensional elliptical contour, when you have holes coming in slightly off center, holes exiting at an angle, you get all sorts of different shaped edges that if you even try to program them exactly, you're really just milling the shape of your profile cutter. It's not a blended radius. In our tool, the whole concept is different because it's the tool following, like a cam follower, it's following the bore, and it's applying that uniform pressure wherever it goes. And a quick video, it's basically what we were doing by hand with a Dremel grinder. This is just under a microscope. It's a stainless steel part. So you can see that cutter pops into the hole. We start it up. And this is exactly that 1-to-1 ratio 90-degree elbow. It's the most challenging thing to deburr.
It's a nightmare for every deburring department.
Because you're really trying to have selective material removal right here at this intersection edge, but you don't want any damage on those back surfaces. So that's what the flexible shaft and the disc allow the ORBITOOL to do. So it's a very simple solution, but it's a very unique way to basically, in all of our advertisements, we keep it very simple. We just show a before and after hole. I don't know if you can see that on the wall there.
Yep, over here.
We don't even show the tool. We just show you this is the problem you got, this is the solution. And in our advertisements, we basically say deburr any cross hole. Because there's very few tools that can truly say do it by hand, do it on the CNC, angled holes, on-center holes, 1-to-1 ratios. It can really do pretty much every hole that you're drilling.
And when am I going to use something like this, where more of a lollipop style, over something with a flat back?
Yeah, that's a great question. So here you'll see we have two configurations. We have a single hemisphere, we call it, and the double hemisphere. The purpose of the double hemisphere is when you're drilling a through hole. So we can see that in this part here. We've got the main bore, and we've drilled a hole entirely through it. So now we're creating two internal edges. If you want to focus on that back wall again, that's what we're showing in that before section.
Oh, back in here.
Exactly. We have the single hemisphere tool, which would be used for elbows and tees. Basically, when you just have one edge, you need to deburr. Or if you're drilling a cross type intersection, you have two edges to deburr, then you would use that double hemisphere tool to hit both of those edges from one direction. So you don't need to index your part, you don't need to take it out of the
all in one shot.
holding. Exactly right.
Now, who do you see, what kind of shops, what kind of industries are you seeing putting these on their floors right now? Who's getting the most excited when they see this kind of product?
So it's a question we get often, and the easy answer is sort of every industry, and the way I answer that is because anyone that's buying drills, if you're drilling holes, you're making burrs. So pretty much everyone uses it. Now, in practical terms, the more common users are aerospace folks, automotive, any industrial kind of hydraulic manifolds, fluid passages.
Oh, definitely. I didn't even think of that, for sure.
Yeah, anytime you have a fluid passage intersecting holes, Or sometimes people require an edge brake because of sharp corners and stress concentration. That's where a breakage of the part can propagate. In recent years, I would say the exciting ones are like aerospace. We even had some racing people doing engines and things. But yeah, like we're in California. SpaceX has been using a lot lately. That's exciting for us as a California company.
Of course.
And so yeah, they're just doing it for their Raptor engine program. But ultimately, when you get down to the part they're making, whether it's manifolds and it's all sorts of intersecting passages for fluid transfer.
I can even think right now of myself. We do this one block that's a hydraulic manifold threaded in one way, and one of the big issues we were having, because it's way down in there, was when those threads go into the crossbore, kicks big burrs out. So we need to go in and get that out. I might actually steal this display and take it home with me.
Yeah, you got the full, and that's the full set there.
Now this does come in a set?
Very rarely, yeah. The one unique thing, what I would say about very rarely, that the unique thing about the tool is you can get one small tool and use it on a range of holes. So it's not like some deburring tools are required to be very close fitting to the hole size. So there you if you have 5 different holes, you need 5 different tools, so you need a set. What's unique about our tool, for example, this when I was deburring this by hand earlier, it's a fairly large hole. I can fit our 1/4 inch cutter into that hole, but I've been doing all my demonstrations with this little 1/8 cutter. And even then, I'm deburring creating some very large
Although
radiuses.
they're all flexible, that still has enough rigidity to be able to take that out effectively.
Right. And in the CNC setting, because we're making this helical interpolation, that means that we're not locked into any one tool for one hole. You can take one smaller tool and interpolate it around the whole diameter of various different holes. And coming back to, I guess, the sizes here, these are the largest ones we offer. We make custom lengths as well. But the thing we're real excited about is a new small tool coming out. So for many years, this was a little 74 thousandths cutter that we've had. It's about 1.8 millimeter. We have a new tool coming out that's 1.1 millimeter, 45 thousandths. So
it's like a hair.
Yeah, it's
10 hairs actually.
Yeah. And the shaft on that one is 15 thousandths, so it's it's under 0.5 millimeter.
Very, very small. Now, where can people find out more information about the ORBITOOL and JW Dunn?
Yeah, so the simplest way, go to our website, jwdunn.com. The story behind that's quite interesting. We wanted originally the name to be Job Well Done, and that was trademarked by someone, so it became JW Dunn. So that's really what it stands for. It's not someone's last name. It's jwdunn.com, Job Well Done. Or if you just search on your search engine ORBITOOL, we're the only ones that have it, that'll come up. And we're located in California. We're very proud to say that it's not something that you hear often. I think in the last few years with various supply chain issues, everything is always in stock. 99% of the time ships out the same day. And in particular, because on the West Coast, anyone that calls us at the end of their workday, it's still 2 p.m. for us.
Ready to go.
Still got plenty of stuff to ship out same day.
And of course, you will be here at IMTS live if you want to come check it out.
We're here all week. We're in booth 432296, the back of the West Hall. I'm here all the way through Saturday.
Thank you very much for joining us today.
Thank you. Thanks for visiting us. See you later.